Okay, as I promised, I'm going to illustrate a lot of large numbers using Python. I get this from this website, kind of combined with another website, but I think this website or this post covers most of them. Just be aware that you cannot get a patent for your programming code, right? So and also I cite the source. You guys need to do the same, right? If it's not yours, tell them where you get it from. That's basic ethics. The first part will be law of large numbers, as we did a while ago. Just import several libraries, and then we are going to eliminate how do you simulate the draw of a dice. Do you guys know what dice is? If not, so these are dice. Okay, so like it has 6 different numbers, right? Different dots on each side. And then we want to show you, first of all, we just draw like this one code from NumPy, numerical Python. This is the code, and then I get the instruction online. It's like a manual, okay? Like you get a car, right? You get a car manual, and then if you use a program, you get a program manual. This draws between 0 and 1 for 10 times. If you guys can count it, right? 2 means a high, right here. High will be 2, so number less than 2 will be 0 and 1, right? Ingredient. And then the second one will be draw like 0 to 4, and then using a matrix 2 by 4 matrix, right? So that's what it looks like. So let's just do some basic experiment here. 10 numbers ranging from 1 to 6. That's a dice, right? So we start from 1, which is a low, and then this is a high, which means 1 to 6, right? And then 10 times. So that's where it draws. Remember, if you just run this differently, you will get a different number because we didn't set the seed. If you want the number to be the same, you need to set a seed. So that's one draw, right? It's like you just throw it one time, give it 3, and then another time give 5, another time give 5. Get another 5, you wonder whether you will get 5 forever. The reality is no. They are independently, identically distributed. Right? You get a 6, you get 3, 3, 5, 6, 1. Regarding those random generators, there are also algorithms behind. If you are interested, you can look at it, how they generate those random numbers. There is a starting point, but we are not going to talk about it. Then you can describe it, right? That's 10 times, right? If you draw it 1,000 times, what will happen? So we can just do it, and then later we put it in an algorithm, right? The line below shows the first number, the first 2 numbers, or the first draw, right? If you and then the first, or you can call it a throw, right? Throw a dice. First 2 throws, and then the first 3 throws. Okay, so that's you can just add those. This will be the first 3. Okay. The first one is 6, and then the first 2 will be 6 and 5. The first 3 number will be 6, 5, and 4. Code below shows how we write a loop to calculate rolling average, right? You just want to see, because we are interested in the average, right? What should be the average? If you throw it many times, it should be the average of those, because we assume that it should be, right? Every number should happen exactly the same probability, and then if you just average them, on average you get like 3.5, right? So that's what we are doing here. So we can just do it 1 time with the average, do it 2 times with the average, do it 3 times with the average, right? Is that making sense? And that's what we are doing. We are going to do it 1,000 times, and then just print out the average. This is what it looks like. Okay, the first time we have 6, right? And then later, when you draw it more and more, you see it approaches 3.5. That's what it says. That's why insurance companies need to have enough people, okay, so that whenever there's accident happening, right, it will be on average close to the predicted probability. It gets really confused with central limit theorem a lot. Okay, central limit theorem says Normal distribution will be the average of any kind of distribution as soon as they're independent and randomly generated. Okay, so the code below shows that we draw from binomial distribution, exponential distribution, geometric distribution, and Poisson distribution. If you draw it many times, the average of all of those distributions will give you something close to normal distribution. Okay, so that's what it looks like. If you can just change this number to be higher, then it will give you something even better. Okay, it will take you a while to run. That's all I have for today, and let's see whether this will run. It's probably too big. Let me just give it another 5 seconds. If it does not show up, I will just stop here. Okay, we will stop here. Thank you.